As we just finished chapter 19 on statistics, all based on one variable statistics, we are now getting into chapter 20, which is on two variable statistics. So you're going to see this phrase come up a lot, bivariate data. It just means there's two variables, and this whole chapter is all about the relationship between those two variables. So the one we're going to be looking at here in just a minute, you can see that a study was done and they gathered an amount of hours that students studied. Then they also gathered how many correct answers those same students got on their following tests. So we're looking at the relationship between these two different variables. So that's the big difference between chapter 20 and chapter 19, is we're now dealing with two different variables and taking a look at the relationship between these two variables. So we're always going to be using our first row of data as the x values and the second row of data as the y values. In the first lesson, all we're mainly looking at right now is the one graph that you need to be familiar with for this chapter, and that's a scatter plot. So we're going to look at that here in just a minute. Once you've created a scatter plot, we can then describe what we see within the graph based on these three standards. So let me get into that. As you take a look at the data that's been given to us here, again, these are the x values are in the first row and the y values are in the second row. And so the first thing that we would do is create our scatter plot by plotting these as ordered pairs. So the first point would be 2, 3. The second point would be 4, 4, so on and so on. And so let me scroll down a little bit so you can see the graph that we're going to get out of this. And so same thing with graphing in the past. As you are creating your own scatter plot, it's going to be really important that you do two things. One is to label the values along your x and your y axis. So you always have to label values. And the other thing you have to do is label the axes for what they represent. So like on a test setting, especially for those of you taking the IB test, you have to label your x-axis as hours of study, for this problem anyway, but you're always going to label it something. And then for this problem, we would label the y-axis as correct answers. And so you always want to label the values as well as the title for each axis that you do. And you don't have to count by ones. You may find yourself counting by 5s or 10s or whatever would make sense with the values that are given to you within the table. So for this one here, you can see the scatter plot that we created. And so I already went ahead and plotted the points that you see within this table. So those are all the blue points that we're seeing here. And so that's our scatter plot. That's the first thing that we're looking at in this lesson. And the second thing we're looking at is how would we describe it now that we have it. The whole purpose of creating a graph when it comes to statistics is to be able to gather information from the graph. And so that's what we're looking at, is now that we have this information graph, how can we interpret what we have? There are three ways that we're going to be able to describe this, and I listed them in order right here in the order that you would do them. The reason I put the form first is because if the data is not linear, so if you determine that it's not linear, then you don't even do steps 2 and 3. So we don't give it a direction or a strength if it's not linear. So the first thing we have to determine is it linear? And if it's linear, then we're going to give it a direction and a strength. And so let me show you a page out of your textbook for this part. So this is on page 570 of your textbook. But you're given some examples here. So you can see that for the data that you get out of your scatter plot, if it seems to follow a linear trend, like this one does, then we can safely say it's linear. If it is doing anything other than this type of a path, if it is curved, if it's circular, if it's wavy up and down, if it's anything other than linear, you would simply say it's not linear. So if it's linear, like the one we're looking at right now, you can see right here, this definitely seems to follow a linear trend heading up this direction. So that would be the first thing that we would say is yes, it is linear. And because it's linear, we can go ahead and answer the next two parts, which are the direction and the strength. The direction is simply the way that you would look at the slope of a line. If it's heading up and to the right, then it is positive. If it's heading down and to the right, then it's negative. And so this one obviously has a positive trend. It's going up and to the right. And the one really important thing you need to get out of that statement is if it's positive because both variables are increasing at the same time. As the x's increase, the y values increase. So that's the whole reason that it's positive, is because the x's and the y's both increase. If it is negative, if it's going down and to the right, that simply means as the x's increase, the y values decrease. So they're kind of working opposite of each other. As x gets bigger, the y values get smaller, and that's what would create that negative trend line doing something like that, going that direction. So that's the direction of it. And again, you can see from this page out of your book right here. So these are just some examples of a positive linear graph. So these are all linear. All 6 of these would be considered linear. And you can see all these are following that positive trend, whereas all 3 of these are following a negative trend. So then the last thing that we would say is the strength of the graph. So whether it's positive or negative, we still give it a strength. If it is more spread out, then it's weaker. The closer they are in alignment, the stronger it is. And so we're kind of going from weak to strong as you look in the graph from left to right there. And this is a little bit open to interpretation, but we're just kind of giving it just a general statement for now. So if it looks fairly spread out, but you can tell that it's positive, then we would say that it's weak. If it's a little closer together, but not perfectly linear, then we just say that it's strong. If they do happen to be in almost perfect alignment, then we could say it's perfect. And so there you can see just some examples of the difference between how we would describe those as far as the strength. Same thing for the weak. So again, let me just kind of recap one more time really quick. The first thing you decide is it linear? So if it follows a linear trend, then you go on to the next part and you describe whether it's positive or negative and how strong it is. If it's not linear, all you say is not linear and you're done. You don't say anything else because it's not linear. So we don't describe the direction or the strength if it's not linear. And so that's the main thing that you got to get out of lesson 1 here, is just being able to create the scatter plot as well as give it the 3 statements that we just talked about for the form, the direction, and the strength. There is a way of doing this in your calculator. It starts on the bottom of page 570. I kind of noted that here at the bottom of the notes. But again, this is another one of those things where it's more trouble than it's worth. This is a very easy graph for us to do by hand. There's no need to go through the calculator steps of having our calculator create this scatter plot. So I always show it because it does exist on your calculator. But like I said, it's way more trouble than it's worth. Come test time, this is something you have to do by hand anyway. So just having it done on your calculator really doesn't have benefit to it. So what we showed in the notes is really what you need to get out of that first lesson.